My name is Richard Gollingworth from Anderson Windows first. Appreciate the opportunity. To be honest, this is my first time ever doing anything like this with multiple locations and having it recorded. So appreciate your patience with me. I'm a little nervous as I go through this, but no, I appreciate the opportunity. Thank you to the AIA of Potomac Valley. Thank you very much, Carter, for the opportunity. Today, of course, we're going to be kind of going over as much as we can cover in regards to NFRC, energy codes, and Energy Star. We're going to be touching base on that, scratching the surface. No one's going to walk out of here expert, but we're going to cover as much as we can to give you a good overview of more of the residential side and the commercial side. We're having some
not hearing anything.
Yeah, hey Larry.
Well, we can't get any audio.
We had that trouble yesterday.
We can hear you. Try again.
Okay, this is just a quick slide that talks about, Anderson's registered provider for the AIA, continuing education system. We are on completion of this first. Can you folks hear me? The locations?
We can hear you in Tyson's.
Everybody good? Okay, sorry about that. All right, so basically what I would like to ask is if we can save any questions for the end of the slides here, presentations, that way I can more effectively answer them for you at the end here. So if you have any questions, you can jot them down. I'm going to help repeat those at the end of the presentation here so everybody at all locations can hear all the questions and we try to get you answers that you're looking for. Material is obviously copyrighted. So our course overview for today, this course describes the physical principles, terminology used to measure heat loss and gain, the thermal characteristics of windows, grading and labeling, standards for product evaluation, and building code requirements relating to windows. So in our objectives today, when you complete this course, you're going to know more about energy terminology and principles of heat transfer, understand the National Fenestration Rating Council, NFRC, and window labels. We're also going to know more about the energy code requirements for windows under the International Energy Conservation Code. And we're also going to review the Energy Star version 6.0 requirements for the EPA. So the basic energy terms for windows and doors are covered under these four areas. U factor, solar heat gain coefficient, visible light transmission, and air leakage. These are the key performance factors that we're going to discuss today. Of the four, U factor and SHGC will have the biggest impact on building energy usage. U factor. The laws of thermodynamics tell us that any time you have a temperature difference, the object that is warmer will lose heat to the colder. Therefore, when the temperature inside the structure is warmer than the outside, heat will be lost to the window or door or wall to the colder outside. The lower the U factor rated for the product, the less heat lost through the product, and the lower the heating cost will be. U factors are defined in BTU per hour per degree Fahrenheit per square foot. The inverse of the U factor is R value, which represents resistance to heat loss. The higher the R value, the more resistance to heat loss. R4 is roughly equivalent to the U factor of 0.25, or 1 divided by 4. The reason behind rating windows, doors, skylights with a U factor instead of an R value is due to the fact that the true R value test is designed for application materials that are homogeneous, meaning they're the same material all the way throughout, such as like insulation. Since windows and doors and skylights are all made up of different materials such as glass and vinyl and wood, the U factor rating is more appropriate for rating those for heat loss. And additionally, energy codes reference heat loss, and that's why we use the factor to measure that. The next one is solar heat gain. In the wintertime, the concern is heat loss. In the summertime, the concern is heat gain. Solar heat gain coefficient is a number between 0 and 1 that describes the amount of heat gain that enters through the entire product. The lower the SHGC, the less heat gain through the product. The less heat gain through the product, the lower the cooling cost and more comfortable you'll be. Also, a lower SHGC may result in using a smaller tonnage air conditioner for a structure. It may result in lower first costs of the structure, potentially lower operating costs. As the NFRC rates total unit, the thickness or the width of the frame and the stack profile is taken into account. A wider frame will yield a slightly lower SHGC than a narrower frame profile using the same type of glass. Similarly, grills will diminish SHGC slightly when compared to products without grills. Visible light transmittance, will be also shown as VT, is an optical property that describes the amount of visible light that enters the room through the product. The visible portion of the solar spectrum are those wavelengths measured between 380 nanometers and 780 nanometers. VT is a number between 0 and 1 that reflects the percentage of visible light that passes through the glass. Visible light transmittance is a whole window rating that includes the frame. The higher the visible light transmittance, the more light is transmitted. Visible light is desired by the maximum daylight that can enter in. So this slide shows the difference between the total unit, visible transmittance, in comparison to the center of glass only, visible light transmission. Glass values for casement windows without grills, taken from our 2018 Anderson Windows product guide, shown here. As the NFRC rates the total unit, the thickness of the frame profile is taken into account. A narrower frame will yield a higher visible light transmittance than a wider frame profile using the same type of glass. Similarly, grills will diminish VT when compared to products without grills. Air leakage. Air leakage is heat loss and gain occurred by infiltrating through cracks in window assembly. Stress and discomfort can often occur by sitting in close proximity to windows with excessive air infiltration. However, windows with higher U factors, such as single pane glass, can create similar discomfort, feel drafty due to the cooler inside glass temperature. Air leakage is expressed in cubic feet of air passing through the square foot of a window area. The lower the air leakage, the less air will pass through cracks in the assembly. All right, on to our National Fenestration Rating Council labels. So this is a sample window product label showing our NFRC performance values. The NFRC certification is an independent third-party program that allows valid comparisons of thermal performance between products. The NFRC certified U factors and solar heat gain coefficients are required to comply with the modern building energy codes and is required to participate in the Energy Star program. As you see, the NFRC was formed in 1989 and again was created to create a fair and accurate comparison between fenestration products. And the NFRC rating is a total unit ratings only, not just the glass, which is important to stress. And you should always look for the NFRC label. The advantages of the NFRC label are that the instant, accurate, direct comparison of energy ratings. The rating applies to all types of products. It covers the whole unit, not just the glass. It eliminates the confusion of deciphering the manufacturer's literature. It provides information to demonstrate compliance to the codes. It also aids in accurate HVAC system sizing and building energy modeling. So now we're going to go through the energy code overview, understanding the importance of each code. So from our perspective, there's three important code books out there. They include the International Building Code, the International Residential Code, and the International Energy Conservation Code. The IBC typically covers all commercial, IRC covers family residential construction, and the IECC provides energy codes for requirements for the IBC, but it's also used for residential. Basically, you find these codes in the IRC. The codes for IRC can be found in Chapter 11. The codes can be found in IBC, often refer to the IEC for their codes. The IECC contains energy requirements for both residential and commercial construction. However, jurisdictions are free to adopt their own I-codes in their entirety, either in part or modified as they seem necessary. So it's very important that you consult your local code official and determine exactly which codes apply in your area. I-codes are published every 3 years. Right now we're working on 2021, and all requirements will change. The good news is there's a widespread adoption of the national codes. The bad news is there's different versions of them, and each state has their own adoption schedule. So possibly each state specifies their own is the IECC. International Energy Conservation Code is one member of the International Code Council's family of building codes. The International Energy Conservation Code is, like I said, updated every 3 years, and each jurisdiction is free to adopt whichever code they would like to use, and they can modify it on their own. And the IEC, what's important is it contains both residential and commercial energy requirements for those states that adopt the IBC, but maybe not the IRC. In many cases, the IEC residential codes and the IRC energy codes are similar, but there's quite a difference between the commercial and the residential in regards to requirements. So how do I know which building codes are in effect in my area? If you log into the International Code Council's website, iccsafe.org, you can click on each individual state and click on the jurisdiction for even more detail. It's going to indicate which versions of the IRC and the IBC as well as the IEC codes are in effect for that state, for that jurisdiction. It even goes into detail to the county locally. Because states can choose whatever version they can adopt, it's not uncommon to see that one version of the IRC and IBC are a completely different version from the IECC. In effect, basically each jurisdiction may have a complete own set of rules, so it's very important that you do get with your local code officials to really understand, because they're all over the map in regards to who might be adopting what in this jurisdiction. So there's a useful site called Building Code Assistance Project, which also helps you break down the commercial adoption as well as residential adoption of codes. This was established in 1994 as a joint initiative between the Alliance to Save Energy, the American Council for Energy Efficient Economy, the National Resources Defense Council, and all the funding for this website and for PCAP for their advocacy and their technical assistance comes from the Department of Energy. PCAP provides custom tailored assistance on building energy code adoption and implementation. They assist with state, local regulatory, and legislative bodies to help coordinate others in regards to environmental interests, consumers, labor, and industry. The BCAP also provides states with code advocacy assistance on behalf of the Department of Energy. They also coordinate with the Department of Energy's technical assistance. They receive funding from the EPA as well as from the State Energy Program in regards to grants. And they also work regionally with efficiency organizations, state energy offices, environmental groups, industries like myself and the Federation, utilities, and other entities. And they basically form to create a collaboration to facilitate mutual goals and goals. So here is the IECC climate zone map for the past since its inception in 2006. There were 17 initial climate zones that were created at first. They've been narrowed down to 8, and it's based on the geography and county boundaries within each state. Due to the different climatic conditions, each climate zone has its own unique energy code requirements by building, by their buildings in their area. And some of the major changes you've seen in 2008, they've created another climate region that they call extremely hot. It's also referred to as Zone 0, which is not on our map here, but it also reflects all the global warming trends over the past 30 years. And with that, most of the U.S. counties have been reassigned to a warmer climate due to that. Energy use has increased by 0.18% due to less stringent insulation and ERV requirements based on this map as well. So while the IECC establishes certain minimum energy code requirements for buildings, there are often multiple ways to demonstrate compliance with these codes and their requirements. This slide kind of demonstrates some of the more significant changes that occurred over the past years with some of the successive additions of the IECC. A lot of them are going to be the changes were in regards to compliance. So that's going to lead us into our next slides here that we're going to be focusing on residential energy code compliance. So how to comply with energy codes. There's two primary code compliance paths: the prescriptive path and the performance path. The prescriptive path lists specific requirements for all of the building envelope components. It's much like following a recipe, where you get specific requirements for the walls, any of the fenestration products such as windows and doors. And they look at the UFU factors and the FHGC of those products as well as HVAC requirements. The performance path establishes an energy budget for the base building. and allows certain trade-offs in energy efficiency of the individual building components, as long as the overall energy budget is not exceeded. This path provides greater builder flexibility, but often requires a computer printout using res check, com check, or a detailed checklist to demonstrate that compliance. As indicated earlier, the IECC climate zone has its own unique energy code requirements for buildings built in that climate zone. Here we're going to look at the prescriptive path, and there's three options under that path. Component rating, meaning the requirements in table R402.1.2, select each component that meets or exceeds the rating in the table and will be deemed to meet the energy code. For example, for house in climate zone 5, selecting a window or door factor a U factor of 0.32 will better meet that energy code requirement. Looking at the first of the paths of the options, the U factor alternative allows basically an area weighted average of the whole house assembly. That area weighted average of all the components must be listed by the components in that table for the house to comply. The second option here is the total UA alternative. This alternative uses software to determine compliance. Total UA for the whole house is less than or equal to the UA from the U factor table. The house then complies. The prescriptive path lists specific requirements for all the building envelope components. There are several options with this prescriptive path to show the compliance. We're going to go through this. So here is the 2018 residential path requirements. This table provides prescriptive U factor and SHGC minimum requirements for fenestration based on climate zone. Note that the 0.32 U factor in the north and the 0.25 SHGC requirements in the south is more restrictive than the previous versions of the code. Note also that notes I and J from the 2009 IRC prescriptive table, which allow higher U factors in SHGC for impact rated products, have been eliminated as well. Please note that basically any wood frame wall R value column that is considered 13 plus 5, 20 plus 5, or 13 plus 10 requires 1 through 2 of continuous exterior foam insulation in the northern climate 6 through 8. Basically complicates the window installation, support, anchoring, flash, and trim. To apply to this pathway, the builder would need to know and provide evidence that each component of his building met or exceeded the minimum requirements listed above. For example, the windows were all labeled with the appropriate NFRC certified U factor in SCC for the given climate zone. But note that area weighting is allowed to meet those prescriptive requirements as well. So some of the exemptions for meeting those fenestration energy codes and the prescriptive compliance are as follows. So up to 15 square feet of glazed fenestration is exempt from the U factor and SCC requirements in the prescriptive table of R402.12. It's often used for decorative glass or things of that nature. There is also an exemption for an opaque door up to 24 square feet from the U factor requirements. These exemptions are only for those following the prescriptive path demonstrating strict compliance with the table. They do not apply when using other prescriptive compliance pathways, U factor alternative, or total UA alternative. Very exciting stuff, I know. Area weighted averaging allows one to meet the intent of the code by compensating for products that do not quite meet the prescriptive requirements with others that exceed the prescriptive requirements. There are upper limits or caps on how high the U factor and SHGC are allowed to be. So I'm going to show you the next slide for that weighted example. So in this example, this is how area weighted average is calculated. This example, even though the patio door has a U factor of 0.33 and it does not meet the prescriptive target of 0.32, area weighted average of 0.31 with the windows and doors, given that the windows have a lower U factor of 0.30, allows the fenestration package to comply. And to our third option. This is a residential code section that describes a total UA alternative as described in slide 23 of that. So the total building thermal envelope of UA, which is the sum of the U factor times the assembly area, is less than or equal to the total UA resulting from using the U factors in the table, and then multiplying that same assembly area as in the proposed building, the building shall be considered in compliance with the table. And the UA calculation shall be done using the method consistent with ASHRAE handbook of fundamentals, and shall include the thermal bridging effects of framing materials. The SHGC requirements shall be met in addition to compliance. Again, exciting stuff. The slide shows the residential energy code section referenced on slide 23 for the U factor alternative. And this is basically showing that the assembly with a U factor equal to or less than that of specified in the table shall be permitted as an alternative to the R value in the table. Use residential trade-off caps. So this basically establishes the upper limits on the U factor and the SHGC when using area-weighted compliance methods. Maximum U factor of 0.48 for climate zones 4 and 5, and 0.40 for climate zones 6 and 8. Using maximum SHGC of 0.50 for climate zones 1 through 3, this caps and prevents forced trade-offs of poor performing envelopes components, so like using single pane glass or clear dual pane glass in the northern climates. That's the reason for the caps. So looking at the residential air leakage requirements. Air leakage through windows and patio doors is regulated by code. Maximum levels of windows and sliding doors in residential construction is for 0.3 CFM per square foot and 0.5 CFM per square foot for swinging hinge doors. Air leakage performance must be demonstrated through testing by an accredited lab to the joint industry standards of the NAFS. Note that these upper limits are not particularly difficult to achieve in most quality windows doors. Many of our operable products test to lower than required by code. Projected or hinge products like casements, awnings, and hinge doors can have a very low air infiltration rate due to their inherent design, whereby they seal in one plane, kind of like a refrigerator, and they also have very low operational force. Conversely, a double hung or gliding window, even gliding patio doors, must find a balance between low air infiltration and low operating force. So, the replacement windows requires all replacement windows and doors to meet U factor and SHGC requirements of new construction. Here we're going to our second path of compliance, which is the performance path. And the performance path establishes an energy budget for the base of the building and allows certain trade-offs in the energy efficiency of the individual building components as long as the overall energy budget is not exceeded. This path provides a greater building flexibility and often requires computer printouts using ResCheck, ComCheck, and a detailed checklist to demonstrate all that compliance. In the simulated performance alternative, an energy modeling program is used to model the energy usage of a standard reference house that is built to serve standard criteria in a given climate zone. So with that, the energy usage of the proposed house is also modeled and compared to the standard reference design. Compliance is achieved when the proposed design meets or uses less energy than the standard reference house. This slide details the new residential energy code compliance option that began basically in 2015 IECC called the Energy Rating Index. So how to use the Energy Rating Index. This basically shows how the climate zone using the ERI is compared. It's also shown in scale and shows the range of ERIs on a score of 100 will be house compliant with the 2006 IECC, which is considered the baseline. ERI of 0 will mean the house is so energy efficient it has no net energy use and is essentially a net zero energy home. Now we're going to look at just a quick shot into the commercial energy code compliance options. And basically you have the American Society of Heating, Refrigerating, and Air Conditioning Engineers using their 90.1 model, which is assuming that the state is adopted that option. The second option for compliance in commercial is using the prescriptive path that we went over. And the third option is total building performance, which are certain mandatory minimums such as air leakage, mechanical systems, etc. So this is a chart for the commercial buildings with less than 30% fenestration, basically showing glazing area from to wall ratio, as well as or 40% with daylighting controls. For buildings with more glazing area, one must use the ASHRAE 90.1. Operable windows are allowed higher U factors for fixed windows. Please note that this table changed dramatically from the 2009 IECC, and that now it's more materially use neutral, where there's no bias based towards metal windows, and they're allowed higher U factors than non-metal windows. see, there's some changes to pay attention to from residential and from air leakage. This is one area in the commercial code that's more stringent than the residential code. Some of the key changes in the IECC from 2006 to 2018, basically because the buildings represent a significant portion of our total energy usage, each new version of the IECC is more stringent than the previous version. U factors for windows and doors have become increasingly more stringent. The SHGC has become more stringent. Wall insulation requirements have pushed for the use of exterior foam insulation, and tighter air infiltration requirements for windows, sliding doors, and non-residential structures, according to 2012-2015. This chart kind of summarizes the changes for the fenestration U factors in the various versions of IECC. The colored cells represent the changes from previous edition. The code development cycle for the 2021 ECC is underway and may result in lowering some of those factors going up to the next change. Here's showing those changes as well for the SHGC, and we're going to assume that in 2021 we can expect some lowering of that for 2021 codes. So some of our compliance options, basically when you're regards to requiring each of the products to have an NFRC certified that's leader label, where the product's performance is taken in consideration from a default table. The IECC requires the fenestration product be NFRC certified and labeled. If not, the product performance has to be determined in compliance from the default table. Attributes such as low E glass or gas bills are not given credit as they're not able to be tested on site. So they're used basically as a negative and require that the frame material and any of those be referred back to the default table. Right, so towards the back stretch of our presentation here, we're going to be reviewing Energy Star and its requirements. So unlike building codes, which are often mandatory, Energy Star is a voluntary program, and it's developed by the U.S. Department of Energy and the EPA. And this slide just shows an overview of the EPA Energy Star program and what it's all about. Energy Star, like I said, is part of the EPA. And it's a voluntary program that helps businesses and individuals save money and protect our climate through superior energy efficiency. In addition to certifying efficient products, in over 65 categories, Energy Star also certifies residential and commercial buildings and encourages efficiency in industrial plants. The Energy Star Windows program sets specifications for windows, doors, and skylights which vary by climate zone. This is showing the current Energy Star map, which is basically shown in the northern. This is mostly a heating zone. The north central is a heating and cooling zone. South central is a cooling and heating zone. And the southern is the most cooling zone. This is showing what that Energy Star table looks like and how it's rated. So this is a sample of our window product label showing the Energy Star map. It's indicating the product compliance applies in all climate zones. It's also showing NFRC performance values. Energy Star does require NFRC certified performance values to participate in the program. So NFRC establishes the fair and accurate credible window ratings, factor, SHGC through the third-party certification. And Energy Star also establishes minimum performance values for the U factor and SHGC that vary by each climate zone, and it's required for NFRC certified values. So in summary, each of the new additions to codes brings increasing stringency. For non-residential structures, you need to pay attention to the 0.20 air requirement that's coming from the established in the 2012 IECC. Pay attention to the impact of exterior foam insulation to meet more stringent wall insulation targets. And most importantly, work closely with your local code official and who has jurisdiction and where the building is located to verify your code compliance. Here are some of the references to the websites where this information can all be found. And if you have any questions, please let me know. That's the end of our presentation. I appreciate your time. Anybody have any questions? All right. Thank you all very much for your time. Appreciate the opportunity, and everybody enjoy the rest of your week. Thank you. Thank you.
You guys have any products, like a lot of those rates were .27, what type of window were those?
Pretty much all of our windows.
Wood and fiberglass?
Yep,
or
so we have everything from vinyl all the way up to
vinyl
wood.
windows that meet that rate?
Yes. So I can, if you want, you got my information. Do you have a card? I can give you a list of specifically what products we've got.
I appreciate it. Thank you. Yeah, what I'll do is I'll send you a list and show our full product line.
Hello, we have a question for you. Hey, Larry.
Yeah.
So you have vinyl clad and aluminum clad windows?
That's correct.
Okay. And they're just different series?
Yes,
Just different series?
I'm sorry? Broke up there.
Just different series windows between the vinyl and the aluminum?
Yes.
Okay, so you're both right. All right, thank you.
If you want to email me your information, I don't know if you can see my email address. I'd be happy to send you that information. So break down the different product lines for you.
No, we're good. You've worked with us before here in Tyson. Thank you very much.
Oh, thank you. Appreciate it.
Bye bye.
Thanks for your time.